So in 2010, there was a giant outburst in Saturn's northern hemisphere. A giant storm eruption occurred, and eventually this spread around to encircle the entire globe at a latitude with about the extent of North America.
Imaging first picked it up, and it was massive. From north to south, it spanned about 9,000 miles. CIRS saw temperature increase like we've never recorded before.
CIRS, looking with its thermal infrared eyes, was able to see two bright beacons of hotspot temperature shining about 150 degrees brighter than the surroundings.
All of a sudden we had these two bright spots. After a month or two, they merged, which was kind of curious, and then it persisted for another 2 years. In fact, it persisted longer than the tropospheric storm.
Typically on Saturn, these occur about every 20 to 30 years. And this is the sixth one that's been seen since 1876. And Cassini was lucky enough to be there at the right place at the right time to see this storm eruption.
Mimas and Tethys are two of, I believe the last count was about 62 moons that Saturn has. And these are examples of these icy satellites, two of Saturn's icy satellites. When you just take images with Cassini, they look normal. With Mimas, it looks like the Death Star, you know, and then you superimpose the thermal maps from CIRS on it. And when you superimpose the thermal maps, it looks like Pac-Man.
Mimas was the example where we saw very warm temperatures surrounding a very cold region, as if it was gonna, you know, chomp it up. Turns out the explanation is kind of is interesting.
The way these are created is due to their orbital orientation as they go around Saturn. They have a leading side which is always towards the front of its motion and a trailing side. And the leading side is intensely bombarded by radiation from Saturn's magnetosphere.
So the high energy particle bombardment is causing this fluffy surface, this icy fluffy surface, to be packed down to a very hard, solid ice surface. And you're changing the way now the surface can heat up and cool down over the course of a day for these moons.
When we look at these in the infrared, we see a cooler region on the leading hemisphere and a warmer region surrounding it. And this gives the exact appearance of these Pac-Man features that we so know and love.
Enceladus is a very small icy moon of Saturn. It's about 300 miles in diameter. It's a moon that we weren't expecting to see a lot from, and it's had a huge impact on the Saturn system.
Previously, we had hints that this moon may be active, stretching all the way back to the Voyager mission. But when Cassini arrived, it was able to detect curtains of icy material venting into space. Then using the CIRS instrument, we were able to zoom in on the South Pole and see the South Pole was much warmer than we expected.
The pattern of temperatures on Enceladus did not match a simple inert body absorbing sunlight and re-radiating it. The question was what to make of all this. The community decided that it must be tidal friction, tidal heating, as Enceladus orbits Saturn.
This tells us that Enceladus is being heated up by the action of Saturn's gravity. Inside Enceladus, we now know that there's a liquid water ocean, and it's this ocean which is venting through these cracks into space.
Throughout the mission, we've learned that it has a subsurface liquid water environment, and with NASA, when you see liquid water, it's follow the water, because that's important for life.
Titan was one of the major objectives of Cassini. We knew from Voyager that Titan was an organic molecule paradise. It just was filled with organic molecules. But maybe one of the key things about Cassini was, instead of a flyby past the Saturn system, Cassini hung around for 13 years. And during that time, even though we were orbiting Saturn, we flew by Titan 125 times.
Titan at visible wavelengths looks like, as everyone has seen, a orangey, hazy moon. When Cassini was built, we put on spectrometers that could see to longer wavelengths outside of the eye's visible range. And so we removed the veil of this smog. We peeled it back. Lo and behold, we saw this amazing, very active surface, river channels and dunes, and we found polar lakes. And we never saw this before because we couldn't penetrate this very opaque, hazy atmosphere.
In In 2013, we made a fascinating discovery about Titan's atmosphere. We discovered a new molecule which hadn't been previously detected, and this is called propylene. And this molecule on the Earth serves a variety of purposes. In fact, it's one of the raw ingredients that we use to make a type of hard rubbery plastic commonly known as Tupperware, which we use in our lunchboxes. And it was really incredible to find this molecule just floating around in Titan's atmosphere. Going all the way back to the Voyager mission 32 years earlier, we'd seen a lighter molecule and a heavier molecule in the same chemical family. But there was a gap at a particular molecular mass, a particular size of molecule that we just couldn't see anything in. So this discovery, using CIRS, filled in this puzzle piece, which had been completely outstanding for about 32 years. Cassini's grand finale is now underway as we dive repeatedly over the planet's north pole and through the gap between the planet and its innermost rings. We're making gravity measurements and magnetic field measurements, and this is information that we didn't get earlier in the mission, so in many ways it's like having a whole new spacecraft mission. Finally, on the very last orbit, Cassini will go closer to Saturn and eventually burn up in its upper atmosphere. The spacecraft will disintegrate and become a permanent part of Saturn.